Given question, find the unknown forces in all the members of truss.
In this question, we have to find out unknown forces in all the members. Let us understand the number of unknown forces at each joint. If we move to the joint A, then it is hinged at point A. Reaction can be in any direction. So we have to draw horizontal component and vertical component at point A. So these two components with unknown forces, and at the same time there is member AB, AF and AE. These three members with unknown forces. That means at joint A there are total 5 unknown forces. At joint B there is BA, BF, BC. 3 unknown forces. At joint F there is FA, FC, FB. That means 3 unknown forces. At joint C, CB, CF, CG and CD. 4 unknown forces in the members. At joint D there are 3 unknown forces. At joint G there are 3 unknown forces. And at joint E there is roller support provided. So we have to show the reaction which is perpendicular to the fixed surface. That means we have to show reaction perpendicular to the horizontal fixed surface, and this is also unknown. At the same time there are 3 members connected to joint E, that is ED, EG and EA with unknown force. So we cannot apply the joint method because we have to find out the joint with maximum 2 unknown forces. So we will move to the section method. Now there is basic rule. We can pass the section in maximum 3 members and not more than that. We have to draw the section line in such a way that it will separate the entire truss into 2 parts. So if we observe this diagram, I can draw here one section line so that it will pass through maximum 3 members. So I will select that members B, C, F, C as well as AE. And if I draw here one section line, then the entire truss is separated into 2 parts, left hand side as well as right hand side. So by using section method, we can find out the unknown force in the member B, C, F, C, A, E. So we will show the direction. So we will show here the same direction for all the members. So I will show the direction which is away from this joint A, that is this whole member is AC, so away from this joint A. Then here is, we will show FC, we will show away from the point F, and for AE we will show direction away from the joint A. So we have to find out unknown forces in the 3 members BC, FC as well as AE. Now at joint A, we have to show horizontal component and vertical component because it is hinged. So we will show here. And at E, we have to show vertical component because of roller support is known as RE. Now if we observe here horizontal and vertical component, all the load on the truss in vertically downward direction. There is no any horizontal force. So this horizontal force at A, that is HA, is equal to 0. So there is only vertical force which is used to balance all the vertical force which are in downward direction. So I will say reaction at point A is RA. Now we will make here one construction. I will draw one perpendicular line passing through C on horizontal line AE. And this line, this point will be point H. Now if we observe in this triangle, if I draw one perpendicular line passing through C, then it will divide this whole length AE into 2 equal parts. That is AH is equal to HE, which is equal to 5 meter, because this total length is mentioned 10 meter. Now in the same way here, this 50 Newton force, 30 Newton force, which is in between A to C, which is also having the same distance, that is this 30 Newton force is applied at the middle point of AC. So how to find out the distance, horizontal distance in between these two forces, 50 Newton and 30 Newton, as well as this 30 Newton and this 30 Newton. So I will draw here one construction. I will drop one construction line on horizontal line AE. So we have to find out, suppose this point is X, then we have to find out this AX as well as XH. But this is the middle point, because in question it is mentioned this distance B to C and A to B is same. So if I draw one perpendicular line, then AX is equal to XH. So 5 divided by 2, that is 2.5. So I will write here AX is equal to XH is equal to 2.5 meter. In the same way AH is equal to 5 meter. Now we will find out the unknown reactions RA and RE. So this whole load that is in vertically downward direction is carried by these two supports at point A as well as at point E, and these are the end points. So we can say that RA is equal to RE, and RA plus RE is equal to 15 plus 30 plus 30 plus 30 plus 15. So we can say that RA is equal to RE is equal to 60 Newton. So this total load is 120 Newton and it is carried by this RA and RE. So at each point load is 60, that is 60 plus 60 is also equal to 120. So we will get this answer. Now if we observe, we have to find out the forces in the member BC as well as CF. These two are the inclined members. So we will find out the angle of inclination with the vertical line. So how to find out? So if we observe in triangle ACH, so how to find out the angle ACH? So we will concentrate on this triangle ACH. So here angle is given CAH is equal to 45 degree. Then this is perpendicular line. So angle CHA is equal to 90 degree. So remaining angle ACH is equal to 45 degree, because we know that total angle for triangle is equal to 180 degree. So remaining angle ACH is equal to 45 degree. Now how to find out the angle made by this FC with this vertical line? That means we have to find out angle of inclination. So it's a for AC, angle of inclination is 45 degree. Now for BFC, angle of inclination is 45 minus 15, because this angle BCF is mentioned in the question 15. So 45 minus 15, that is equal to 30 degree. So this angle is equal to 30 degree. Now we will find out this height CH. So how to find out this height CH? So again in triangle AHC, tan of 45 is equal to this opposite side CH divided by AH. So AH is equal to 5, tan of 45 is equal to 1, so CH is equal to 5 meter. We will consider the left hand side part of the section line. If we consider the equilibrium of the diagram, then we can apply summation of all vertical forces is equal to 0, summation of all horizontal forces is equal to 0, and summation of moment of all the forces about any moment center is equal to 0. Now if we observe, this BC as well as FC are the two inclined members. So we will resolve these members into two components, horizontal component and vertical component. So I will resolve here. Now if we observe, this member BC is making an angle of 45 degree with vertical line. That means with this vertical component it is making same angle, that is equal to 45 degree. So how we can say that this component, that is BC cos of 45, and for the horizontal component BC sin of 45. So this is nearby to 45 degree. Now in the same way, if we observe, this FC is making angle 30 degree with vertical line. So for this vertical component it is making angle 30 degree. So we can say that FC cos of 30 for the vertical component, and for the horizontal component FC sin of 30. Now this A to H, this force A to H is the horizontal force. Now we will apply the first rule, summation of moment of all the forces about point C is equal to 0. Now why we have taken this point C? We have to find out unknown forces in these three members. Now if we observe, this member BC as well as FC is passing through the point C. So it will become 0. And if we apply this rule, then there is only one unknown force, AH. And we can easily find out this one unknown value. So we will apply the moment of all the forces. So if we observe, these two forces will become 0. Then here is AH, or we can say AE, because if we extend this, then here is the point E. So we can say that AE, that is this force multiplied by perpendicular distance. So this is the line of action of force, and from point C perpendicular distance is CH, and CH is equal to 5 meter. So force multiplied by perpendicular distance. Now if I move the compass in the direction of AE, then it will move in this anti-clockwise direction. So we have to use negative sign. So minus FAE multiplied by 5. Now we will move to the next, that is 30 Newton. So for 30 Newton, this is the 30 Newton which is acting in vertically downward direction. Now if I move the compass about point C in the direction of 30 Newton, then here is the anti-clockwise direction. So again minus sign. So minus 30 multiplied by perpendicular distance. So the distance from this is the point X we have seen earlier. If I drop one perpendicular, so what is this distance XH? So XH is equal to 2.5 meter. So minus 30 into 2.5. Then next is 15. So if I move the compass about point C in the downward direction, then here is anti-clockwise direction. So minus 15 multiplied by perpendicular distance A to H, that is 5. Now this 60 Newton, that is RA. Now if I move the compass about point C in the direction of RA, then here is clockwise direction. So plus 60 multiplied by perpendicular distance is 5 is equal to 0. Now in this equation only one unknown force FAE, and FAE is equal to plus 30 Newton. So because of the positive sign of magnitude, the nature is tension. Now we will move to the next rule, summation of all vertical forces is equal to 0. So summation of FV is equal to 0. So if we observe, for upward direction force use positive sign, and for downward direction use negative sign. Now this is the horizontal force AE, so we are not going to use this. So BC cos 45. So I will use here FBC. So force in BC, that is FBC cos of 45 plus FFC cos of 30 plus the 60 minus 15 minus 30. Now if we observe, all these vertical forces are covered is equal to 0. Then we will move to the next, because here two unknown forces are there. Now we will move summation of all horizontal forces is equal to 0. So which are the horizontal forces? So these three are the horizontal forces. So FBC sin 45 plus FFC sin 30 plus FAE. FAE is equal to 0. Now FAE is equal to 30, so we can put here value. So we will get the two equations in terms of two unknown terms, FBC as well as FFC. So we will simplify this and we can calculate the value of FBC as well as FFC. Now we will simplify this equation 1. So cos 45 0.707 FBC plus 0.866 FFC, and now this constant term we will move to the right hand side. So its answer is minus 15. So again we will give here equation number 1 because it is the simplified form. Now we will move to the next. We will again simplify this sine of 45, that is 0.707 FBC plus 0.5 FFC is equal to, now this FAE we will transfer to the right and its value is 30, so minus 30, and this is the equation number 2. Now if we observe, coefficient of FBC is same, plus 0.707 for both these equation. Now if I subtract equation number 2 from equation number 1, then this will become negative and this will also become negative. So this plus and minus will be getting cancelled. So equation 1 minus equation 2 will give us 0.866 FFC minus 0.5 FFC is equal to, now on right hand side, minus 15 minus 30, that is minus 15 plus 30, which is equal to 15. So again we will take this common as a FFC, and when we calculate this we will get 0.366 FFC is equal to 15. So FFC is equal to 40.98 Newton. So its answer is positive, that means magnitude is positive, so nature is tension. So I will write here tension. Now we will put this value in equation number 1, that is FFC is equal to 40.98. Then we will get FBC is equal to minus 71.4 Newton. So its magnitude is negative, so nature is compression. So how to write? With magnitude 71.4 we have to mention nature is compression. If we observe the joint B, then the force in one member BC is calculated. So there are only two unknown forces in the other two members. So we can apply the joint method. So we will show here the joint B. We will show 30 Newton force in downward direction as it is. Then here is the member FBC. We have to show the direction of forces in all the members in the outward direction from the joint B. So we will apply the same rule for all the joints. Then for this member we will show FBF, and for this member we will show FBA. So these two members we have to find out the unknown force. So we will apply the equilibrium at this joint B. So this joint B, if we observe the member BA and this member BC is the part of AC. So we will apply the rule summation of forces normal to AC, that is perpendicular to AC, is equal to 0. Summation of forces parallel to AC is equal to 0. Now the forces in the member BC and BA, these two members are parallel to AC. And the force in the member BF, this BF is perpendicular to AC. Now here only one force which is in vertically downward direction. So we will resolve this force into two components. One component is parallel to AC. So this line is along AC. So I will resolve here parallel to AC, and other component perpendicular to AC. So this component is perpendicular to AC. So we will draw one parallel line. So how to decide its value? So if we observe this parallel line, that is this AC, making an angle of 45 degree with vertical. So this is also vertical line. So here is angle 45 degree. So how we can define this component? It is nearby to 45. So 30 cos of 45. And here 30 sine of 45. Now we will apply the rule summation of forces normal to AC. So if we observe normal, that means perpendicular force is FBF as well as 30 sin 45. Now for these two forces, both are in the same direction, that is in the downward direction. So for downward direction use negative sign. So minus FBF minus 30 sin 45 is equal to 0. So its answer is FBF is equal to minus 21.2 Newton. That means we can write here 21.2 Newton with compression nature. Whenever the answer is negative, we have to show nature is compression. Now we will apply the second rule, summation of forces parallel to AC. So which forces are parallel to AC? So here 30 cos 45, then FBA, FBC. Now if we observe, this FBA and 30 cos 45 is having the same direction, but FBC is having the opposite direction. So we will apply here, if we apply FBC with positive sign, then we have to show FBA and 30 cos 45 with negative sign. So minus FBA plus FBC minus 30 cos 45 is equal to 0. Now this FBC we have calculated. So this force in the member BC with by section method we have calculated minus 71.4. That is the nature is compression. So we have to use magnitude with negative sign. So we will put the values. So minus FAB minus 71.4 minus, now this 30 cos 45, that means 21.2 is equal to 0. So FAB is equal to minus 92.6 Newton. So here also nature is compression. So we will write 92.6 Newton with compression nature. Now we will move to the joint A. We have to show this 15 Newton force as well as 60 Newton force as per the direction. Now we have to show the forces in the other members, that is the direction of force in other members is in the outward direction from this joint A. So this is the common rule we have to apply for every joint. Now this member is AB, so I will say FAB. Then this member is AF, so I will say FAF. And this member is AE, so I will say AFAE. Now these two are the inclined members. So for AB member, it is the part of AC, and AC is making angle of 45 degree with vertical. So I will resolve this into two components. So it is making angle 45 degree with vertical. So we can say that this vertical component FAB cos of 45, and here FAB sin of 45. Now in the same way we will resolve this AF. So we will resolve AF into two components. So this AF is making angle of 30 degree with horizontal. So with this horizontal component it is making angle 30 degree. So I will say that FAF cos of 30, and here FAF sin of 30. Now we have to find out value of FAF. Now we will take the summation of all vertical forces is equal to 0. So when we consider this, then we have to take FAB cos 45, FAF sin 30, 15 and 60. For upward direction use positive sign, for downward direction use negative sign. So for the upward direction FAF sin 30, then FAB cos 45. So this is also in upward direction, so use here plus sign. Then here minus 15 plus 60. Now when we solve this, we have to find out the answer. So here FAF sin 30. Now this FAB we have to use with magnitude negative, because we have used here the same outward direction for each member. So minus 92.6 cos of 45 plus 45, because if we simplify this, 60 minus 15 is plus 45 is equal to 0. we will transfer all these terms to the right hand side. That is 92.6 cos of 45 minus 45 is equal to FAF sine of 30. Then FAF is equal to 40.9 Newton. So it is having positive sign. So nature is tension. Diagram is symmetric about this CH. So we can say that this force in the member AB is equal to force in the member ED, and it is minus 92.6. That means nature is compression. So for compression nature, how to show the force? So here I have shown this is the joint and this is the member. We have to show direction of arrow towards the joint. So for AB, we will show the direction towards the joint. So here is the joint A and here is the joint B. So we will show here the direction. So both the direction are opposite but magnitude is same, 92.6. Now BC and DC. So here is the member BC and on that side there is the member DC. For that we have to show compression nature and magnitude is 71.4. So for compression nature we have to show arrow towards the joint. Now next is BF and DG. So for BF and DG nature is compression with magnitude 21.2. So for compression nature we have to show arrow towards the joint. And on that side there is the member DG. Now next is AF and EG. So here is AF and on that side there is EG. So here magnitude is 40.9 and nature is tension. So for tension we have to show direction of arrow away from the joint. So here is the joint A and here is the joint F. So we have to show arrow away from the joint. Then FC and GC. So here is FC. So we have to show nature tension where arrow is away from the joint. So away from joint F and away from joint C. So this is the arrow. Now AE. So for AE nature is tension and we have to show arrow away from the joint. And here is the point E. So we will show here. So this diagram and this table is the final answer.